This is what a system throwing a fit looks like. At 2 a.m., I woke up to identical failure messages for my automated midnight jobs. Both the GitHub backup and the Obsidian pull had crashed. The system returned the exact same error for both processes. Many developers treat agent maintenance like a failure of the code, but a system that surfaces its own errors and tells you exactly what broke is actually a healthy architecture defending itself. To get the system back to green, we need to execute 3 precise steps: fix the cron script paths, cut down context bloat, and lock our model settings to stop surprise bills. Following these 3 debugging steps ensures the agent operates within its technical limits, maintaining high uptime while keeping API costs under control. Let's start with the midnight crash. The error log showed a path resolution fault that completely blocked the scripts from running. During Phase 5, we used symlinks as a shortcut to organize the files. It's a common trick to keep root directories clean. Hermes' security scheduler resolves real file paths at runtime. File links routing outside the designated script boundary box are instantly blocked. To fix this, we delete the symlinks and physically move execution files like backup.sh directly into the scripts folder. The pathway verifies and completes. After moving the scripts, a manual test run fired off perfectly. 5,364 files pushed cleanly to the data vault. When you enforce strict directory boundaries, you eliminate ambiguity. The execution environment becomes completely closed off, ensuring automated tools run securely and predictably every time. With the scripts fixed, I checked a community post about cutting token costs, but applying optimization advice blindly to a customized setup often creates more problems than it solves. This minimal diagnostic readout shows my context usage is sitting at exactly 3%. Features like prompt caching already keep the overhead extremely low, so heavy compression isn't necessary. Another common tip is optimizing tool search. I run 0 MCP servers. Avoiding those integrations in the first place naturally prevents context bloat without needing extra code. There are highly effective optimizations out there, like compact file readers, which save about 14% on file reads. But since that requires rebuilding the entire container, we leave it in the queue for now. This diagram demonstrates how we handle retrieval memory. Instead of dumping all past entries into the system, we configure a hard limit of 2,200 characters to cap the data injection and force it into a tightly bounded space. Checking that constrained memory file showed it was at 91% capacity. I manually reviewed the contents to ensure only intentional data remained, like voice rules, execution constraints, and specific cron IDs. Stripping out tool bloat and strictly capping the memory volume directly drops the computational load, which translates to significantly lower API processing costs. There is one more optimization to check, and it involves a hidden financial trap built right into the agent's logic: auto-switching models. Many users run a free model. They hit their daily limit, the system silently triggers a fallback, draining their credits without warning. Here is a macro view of the YAML configuration file. You must locate this specific line and make sure model-fallback is set to false. Save that setting to permanently lock in your preferred model, then restart the agent. By establishing these deterministic locked configurations, you guarantee absolute predictability in your system's operating budget. No auto-switching, no surprises. We now have a system with secure script paths, strictly capped context, and a protected API budget. The memory bank is dense, fully intentional, and operating at a total daily cost of merely 16 cents. The true test comes tonight at midnight. When those scheduled crons trigger, we will know for certain that the physical script movements hold under pressure. Once verified, we move on to Phase 6. That means evolving the architecture into a multi-agent control room setup. A system that wakes you up at 2 a.m. to tell you exactly how it broke is a system that works. Building that kind of diagnostic clarity is the foundation